So now what is maximum power theorem? So in maximum power theorem, we are making sure that so the load, the resistance which we are connected in the output circuit, it might be the appliances. So the maximum power has been received at your appliance. Yeah. So here let's say that device is nothing but having the resistance which is the capital R. So it states that the output power of a source of EMF is maximum when the external resistance is same as that of your internal resistance of the cell. Yeah, so this resistance which is nothing but R. So under that condition we can say that, so under that condition we can say that the maximum power has been received by that your output. Yeah, so that is what we can say about the maximum power theorem. Yeah, so this is what we can say about the maximum power theorem for this case. Yeah, so again let's say that what is the maximum power then? So which is nothing but I square into R. Again I is nothing but, similarly we can write it down, that is a V upon R. So this is E upon R plus R, so that is a square of that, and this is R again. Further I can write it down, that is a E square upon R plus R whole square multiply by R. So this is nothing but power. So further I can just write it down, E square R. So this is how I can write it down, R square plus that is a 2RR and plus R square. Yeah, so if I just make sure that, so again further simplifying that, so this is P, and again just write it down as it is, E square upon R. Yeah, so this is your E square upon R what we have written, and this is R square plus 2RR plus R square. Now what I will do over here, so I will just add, yeah, so again, so further I will say that, so this is your I is equals to what we have written, that is your E upon R plus R. Now we will just simplify it further, so that is what we have written over here. So this is R square, again I will just, that is your R square, again I just written that, that is a 2RR plus R square. So we can do it one more by way, so that is your E square into R, then this one further I can just write it down where I have just say that, so R plus R, so this is R minus R. Yeah, and again further I can write it down, that is a 4RR. So if you just check it out once again over here, so how it will just happen, so this is E square upon R, so that is a R minus R. Okay, so this is again, obviously if you just simplify this bracket you will get the same thing, you will get the same thing. So for the maximum power, so now definitely you get the maximum power. So what we want that, so this term, so this R minus R has to be 0. Yeah, so this term has to be 0. So under that condition, if I just put that condition, so this R minus R has to be 0, then you can say that, so this R is equals to R. Yeah, so this is the condition for your P max. So this is what we can condition say that for P max your internal resistance has to be same as that of your external resistance. So under that condition you will get the maximum power. And again if you just want to find out that what is that maximum power, so further you can say that, so this is E square upon R. Yeah, and we have just say that, so this is your R plus R, that is a whole square, so this is E square upon R. So obviously we can say that further, so just put that is a R plus R, so this is a 4R square, so this is a E square upon 4R. So that is your maximum power output. So this is your P max, and which we can say that it is a E square upon 4R, which is the maximum power output that you will get it over here. So this is how we can calculate over here. So the what is the maximum efficiency of source of your EMF? Yeah, so the same thing we have just seen that, so that is your output, so which is VI, and again I just said that, yes, so we have just seen that, so output upon input, again V, again I just told you that, so this is what we can say that, yeah, so this is V upon epsilon. So this one, yeah, again we can say that, so this is your VI, so that is your output power upon input power. Okay, so further this V you can write it down one more thing, so this is V is equals to your IR. Yeah, So this is your IR and this is your R plus R. Okay, so this is your R upon R plus R. So now further we can say that, so R is equals to your 2R, and your efficiency you can say that it is a 50%. Yeah, so even in case of your maximum power output, where I am assuming that for maximum power output your R is equals to R, still your efficiency is not going to extend beyond 50%. So that is the maximum efficiency of a source of EMF that you will get. Now what is the efficiency of electric device? Obviously again the efficiency of electric device is as the ratio of output power to the input power. So that is what we can call as a efficiency of a device. So in case of your electric motor, we know that obviously that is a efficiency is nothing but minus your I square into R. Yeah, so for maximum power output, so that dP by di has to be 0. So epsilon minus 2IR has to be 0. So E is equals to 2IR. So E upon that is a 2 your R is equals to I. So this has to be current to get the maximum your output power from the source. So this is the value of current that you should get to get the maximum power.